do is we're going to avoid converting forms. So I don't want to get this into vertex form because I'm sketching based on all of the important pieces of the graph, okay? So you don't have to complete the square to get this in vertex form, okay? I'm going to give you a little formula, and this little formula might look familiar. The formula for the axis of symmetry, okay? From standard form, the axis of symmetry is that x equals opposite b over 2a. Okay? Does that look familiar? Where have you seen that pop up? Yeah, in the quadratic formula. So real quick, just because this is interesting, I'm just gonna, you don't have to write this down, but this is the quadratic formula, right? Okay, now look, the axis of symmetry is this, right? That's the axis of symmetry. And the quadratic formula solves for the zeros, or the x-intercepts. So one is on the positive side of the axis of symmetry, the other one is on the negative side. So that kind of also goes to show that the axis of symmetry is in the middle, and everything else is just symmetric, right? Hence, yeah, okay? All right, so to find the axis of symmetry, that's the first thing that we find. So I'm gonna put a little number 1 here, because that's the easiest thing to find first. Okay, we're just gonna plug in numbers into our formula for the axis of symmetry. So opposite b, so -4, because b is positive 4, divided by 2a, and a is -1. So we're looking at -4 divided by -2, which ends up being positive 2, right? Okay, so our axis of symmetry is the line x equals 2. Okay, now if we think about the axis of symmetry, what other attribute sits on the axis of symmetry? Well, the x-intercepts will be on, they'll be symmetric, but the vertex sits on the axis of symmetry, right? So the next thing that I'm going to find out is the vertex. And guess what? We already know half of the vertex, because if it sits on the axis of symmetry, that's the x-coordinate. I just need the y-coordinate, right? So to get the y-coordinate, oh, sorry, I didn't label what I was finding here. I was finding the axis of symmetry there. And now I want to find the vertex. And I know that the x-coordinate is 2, so to get the y-coordinate, all I'm going to do is plug in 2 for x in the function. So that's what function notation is for, right? It says, okay, I'm the function of 2. So if I plug in 2 in the function, so replace x with 2, so I'm replacing x with 2, so this will be 2 squared is 4, and then the negative is happening after the fact, so -4 plus 8 plus 5, which is 4 plus 5 is 9, right? So the vertex is the point 2, 9. Okay. All right. We'll wait till I gather all the things before I actually graph it, okay? All right, so the next thing that you can find is, why don't we just do the x-intercepts next? So x-intercept, I'm going to do that third, okay? And x-intercepts, we solve a related equation, okay? So I'm going to have to solve a related equation. And what is the related equation that I'm going to be solving? Well, that's when any x-intercept is when the y is equal to 0, right? So I'd be solving the equation 0 equals -x squared plus 4x plus 5. Okay. Oh, and we've only spent like the last month solving these, right? We've got all these methods. We've got the factoring method. We've got the square root property. We've got completing the square. We have quadratic formula. And now we have a problem in its natural habitat, and we get to choose what's going to be the best method? Well, right away, if we look at it, we can't do square root property because there's a bx term. Okay, if there's a bx, we can't do the square root property. Okay, but if we can factor it, we should. If this will factor, let me get rid of my underline here. We should factor it. So to decide if you can factor it, you can either calculate the discriminant or you can just try to factor it and see. I honestly think just trying to factor it is easier than calculating the discriminant, right? So like, if I'm gonna try to factor this, I have to pull out a -1 because you have to factor that out as a GCF if we're choosing factoring. So that leaves us with x squared minus 4x minus 5. And then you just got to ask yourself, well, will this trinomial factor? Could you factor that? Yeah. Oh, and if it will factor, that's the one we got to do. It's less work. So I'm going to choose factoring for this one. Okay, so now I have 0 equals negative x minus 5 times x plus 1. So either x minus 5 equals 0 or x plus 1 equals 0. So our two values of x are positive 5 or negative 1. Okay, now, I had to solve a related equation because what was I trying to find? X-intercepts. Those are places on a graph. I'm not going to put solution sets around these because I'm finding an attribute on a graph. So I'm just going to come up here and I'm going to jot those down. My x-intercepts are 5 and negative 1. See how they're like two separate blanks there? So you can just write in those numbers. Okay? Excuse me. Yeah.
Why did you like take out the negative from the x but then like not bring it down?
Oh, good question. So in the zero product property, you set each factor equal to 0 and solve for x. But this factor right here is a factor of -1. And will -1 ever equal 0? No. So we really only need to set the factors that have an x in them equal to 0. Yeah, good question. Okay, now y-intercept. Let's do this one fourth. Okay, y-intercept, if an x-intercept is where y is 0, then for a y-intercept, that must be where x is 0, right? So we're just going to plug in 0 for x, or in other words, evaluate the function when we replace 0, or when we place x with 0. So this would be negative 0 squared plus 4 times 0 plus 5. So just 5. Cool. So y-intercept, I could write 5, or if you want to put the entire coordinate point, you can write 0, 5. It's fine. Okay, now symmetric point, I'm going to come back to that one, okay? I'm going to come back to that one after I start graphing. Now that we've got all the things, we're going to sketch a graph on the grid, okay? So, you know, I'm just going to, let's see, looks like I just need to go out 5 in each direction. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I'm just going to try to jot down these things. So x equals 2 is my axis of symmetry. Ooh, this is rough to do on the screen. Wow, okay. Here's my axis of symmetry. 2, 9 is the vertex. Okay. My x-intercepts are 5, 1, 2, 3, 4, 5, and -1. And y-intercept is 5. Okay. Okay, so we start to see this take shape. Now, symmetric point, what does that mean? Well, these things are full of symmetric points. So what one are we talking about? When we write symmetric point on here, we're talking about the point symmetric to the y-intercept. Symmetric to the y-intercept. So basically, to get this point, I'm going to reflect the y-intercept over the axis of symmetry. Okay? So you can use your graph and you can say, all right, how many x units away was 2. So on the same y, just go 2 to the right of the axis of symmetry, and we're right here at the point 1, 2, 3, 4, 5. Okay, so that would be the quote symmetric point. And then you have enough information to make your sketch. And this is a sketch not made of points plotted from a pattern. Ooh, there's a lot of keywords. But it's points plotted from all of the important things. Okay, all of the most important points. Figure out where those go when we plot them. Okay? But the whole point of this, right, is proving each of these things algebraically. Using this formula for the axis of symmetry. Plugging that in to get the vertex. Solving a related equation to get your x-intercepts. Choosing the best method to do that. And then, we actually, did anyone catch that there's a little bit of a shortcut to y-intercepts? It's just always your c. Okay? So if you're looking at a graph in standard form, c is always your y-intercept. So there really is not work you are going to have to show for y-intercepts. Yeah?
Can you explain the symmetric point?
Yeah, so this is just to round out our graph. If we figure out where our y-intercept is, we're just going to get its symmetric point. And quadratics are full of them, right? Because this is a symmetric graph. So we just reflect the y-intercept over the axis of symmetry to get the symmetric point. And we'll have practice because we're going to do that again. Okay? All right, now each of these that we've chosen to do, they have a little something different about them. Okay? So let's do example 2, which is number 8 from worksheet 9. Again, we're going to start with the axis of symmetry, that little chunk of the quadratic formula, negative b over 2a. So I'm going to find that, or opposite b over 2a, I guess. X equals, I need x equals because it's a line, right? Opposite 6 over 2, whoops. What happened here? Opposite 6 over 2 times 1. So that's negative 3. So AOS is x equals negative 3. Plug in that into the function to get the vertex. So f of negative 3 is going to be negative 3 squared plus 6 times negative 3 plus 9. So that's 9 minus 18 plus 9. Ugh. Okay. Oh, and that's 0. Cool. So our vertex is negative 3, 0. All right, now I know we might notice something like, hey, that's also an x-intercept. Yeah, but I also have to prove it algebraically, right? So I need to solve a related equation. So that's when our y is equal to 0. Okay. Yeah, so you can notice that that'll factor. That's also a perfect square trinomial. So you could technically rewrite this as x plus 3 squared. And then we can use the SRP. Because there's no bx term now, right? So this is, we sort of just do this. But if you factor it, you're going to get the same answer, right? Square root plus or minus square root. So this is plus or minus 0 equals x plus 3. Well, how many unique answers is that going to provide for us? Just one. So just 0 minus 3 is negative 3. So negative 3 is x. So we also proved that that's also the x-intercept. So x-intercept is just one of them. We have a negative 3.
Can you not write the x-intercepts in ordered pairs?
You can. You can. So the way that this is set up is just to put the number in the blank, and that's okay because we're labeling the intercepts. If we were not labeling the intercepts, we would absolutely have to put the entire coordinate point. Okay? So yeah, it's fine to do either. Y-intercept though, we don't have to show work necessarily for the y-intercept because it's just c. So our y-intercept is just 0, 9 or 9. Right? It's whatever our c value is. So y-intercept, I'm just going to put 0, 9 or 9. Okay? All right, and I like to wait to do my symmetric point because I like to actually reflect it, but if you can just like figure it out, that's great too. Okay? All right, so let me try to put some of this stuff on here. We know we've got going out that way, y-intercept 0, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so negative 3, 0 is a vertex. Axis of symmetry is right here. Our y-intercept is 0, 9. So I just got to figure out what is that other point. So it's 3 units away from the axis of symmetry? Or is it, yeah, 3 units, so 1, 2, 3. So what is that point right there? Negative 6, 9? All right, and then we have enough information to, oh, that looks horrible, I'm so sorry. That's not supposed to look like a pair of tweezers or whatever it is I have that looking like. Okay? All right, so sometimes that happens where our vertex and our axis or our x-intercepts are the same. Okay, any questions so far? Okay, let's do this one because I got one of each kind of scenario you're going to come across here. Okay, so example 3. Hop right in, we'll find the axis of symmetry. So this will be negative 4 over 2 times negative 2. So that'll be negative 4 over negative 4, which is 1. So our axis of symmetry is x equals 1. Okay, now I want my vertex, so I'm going to plug that number into the function. So I'm going to find f of 1. No, I do not want you to be my default. Thank you. Okay, so this will be negative 2 plus 4 minus 3, which is negative 1. So our vertex is 1, negative 1. Okay, let's figure out these x-intercepts. Solve a related equation where 0 is equal to negative 2x squared plus 4x minus 3. Okay. So now we got to choose a method. Let's see. You don't have to jot all these down. I'm just doing this for illustration purposes. Like, okay, well, not square root property. Will this factor? I mean, you can try to factor it. Like, factor out your negative 2x squared minus 4x, and that'll be plus 3. And then you can ask yourself, will this work? Factors of 6, 2 times 3 is 6. That add to negative 4? This one's not going to factor. Okay, so my choices now are completing the square or quadratic formula. And, you know, it's our choice. Don't matter. How about quadratic formula?
Yep.
Let's do quadratic formula. I would say complete the square, but we have a negative 2 as our a value, and then an odd. I just don't want to deal with it. Okay, so let's do the quadratic formula. That's what I'm going to choose. So x equals negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is negative 2, times c, which is negative 3, all over 2 times negative 2. Okay, now, come here, calculator. What is negative 4 squared? Whoop, not negative 4, but I guess it doesn't matter, right? Because you're squaring it, so it doesn't make a difference. Minus 4 times negative 2 times negative 3. Whoa. Ah, negative 8. So negative 4 plus or minus the square root of negative 8 all over negative 4. Okay, hold on. Now we got to think. Do I keep going or not? Well, what am I doing? I am taking a graph. I'm trying to sketch a graph of a quadratic function. And this is what I'm working with. A Microsoft Word set of axes from probably like 2011. Do you think I can graph complex numbers on here? No. Absolutely not. So to answer the question, where's the x-intercepts?
5.
Well, there are no real x-intercepts, right? There are none. So because of that, there are no real x-intercepts, and that's what I'm working with, right? So what do I write up here? I write none. There are no x-intercepts, okay? Because we are not going to pull out a complex plane on that little piece of paper. It's not going to happen, okay? We're just going to go, nope, no real x-intercepts. Okay, but this is the work that proves that, right? I had to get all the way to here to prove it. All right, now y-intercept, this is kind of easy for us. It's just c, right? So do I have to write it out, or can we just go straight to 0, negative 3? Let's put these things on the graph. Let's see, what are we working with here? Let's see. Let's do a few of these and see how that's good enough. Let's see, our vertex is 1, negative 1. Axis of symmetry right here. Y-intercept is 0, negative 3. And then you can kind of see, oh yeah, so let's reflect to get the symmetric point. That's just 1 unit on the other side of the axis of symmetry. So our symmetric point is 2, negative 3. And then you, as we connect it, you can kind of see, oh yeah, that makes sense why when we were trying to solve for the x-intercept, we couldn't do it because there's no x-intercept. Okay? But I needed all this work because that's what proves, right? That's what proves why there's no x-intercept. All right, you have any questions so far? I got one more that we're dealing with, okay? All right, let's plug and chug these numbers. Axis of symmetry, negative b over 2a, so negative 12 over 2 times 4. That's negative 12 over 8, ooh, fraction. Negative 3 over 2. Axis of symmetry is x equals negative 3 over 2. And then we need our vertex. So we are going to plug in negative 3 over 2 into the function. So 4 Alright, so PEMDAS, I gotta square that fraction first. So that'll be a positive 9 over 4. So I've got 4 times 9 over 4. And then 12 times negative 3 over 2 is negative 36 over 2, which is negative 18 minus 11. And then 4 times 9/4, these just cancel. So we have 9 minus 18 minus 11. Negative 20? Cool, that sounds fun to graph. Negative 3 over 2, comma, negative 20. Okay, but luckily this is just a sketch, right? So it's not, doesn't have to be beautifully
So we're gonna go back.
beautifully accurate. What else? Oh, x-intercept. That's next. X-intercept. Related equation for our x-intercept. Cool. So we're going to set our function equal to 0. So 0 equals 4x squared plus 12x minus 11. Okay, let's see. What are we going to do? Here's our choices. All right, no SRP. Will this thing factor? Would be nice, but I don't think it will.
No.
Nope, not going to factor. So completing the square, quadratic formula. Why don't we just do quadratic formula? Can we just do that? I'm not feeling like I really want to cook a Thanksgiving dinner from scratch right now. I've got to do that pretty soon. Okay, so x equals opposite b, negative 12, plus or minus, big ol' square root, b squared, so 12 squared, minus 4 times a, which is 4 times c, which is negative 11. Ooh, square root too short. Fix it. There we go. All over 2a, 2 times 4. This smells like there's going to be some simplifying going on. Negative 12, plus or minus. Okay, I calculated that last period. I'm pretty sure it's 320. It's 320. Take my word for it. 320 all over 8. And then, yeah, we are going to have to simplify that. Okay, so I feel like this might divide by 64. So I'm trying to find the largest perfect square factor inside of 320. And it does. So 64 is the largest perfect square factor. So where am I going to jot this down? Here's some space, okay? So the square root of 320 is the same thing as the square root of 64 times 5. And what's the square root of 64? 8. So this reduces to 8 root 5. So x equals negative 12 plus or minus 8 root 5 all over 8.
The triangle.
Yes, the triangle, exactly. I don't have to split those up because this is real. Okay, so I can look at this triangle. Is there a number that will divide by all of those? 4. So let's divide them all by 4. Negative 3 plus or minus 2 root 5 all over 8. Nope, not 8. I forgot to divide that by 4.
2.
2, not 8. That becomes a 2. Okay, so those are the x-intercepts. So I'm just going to leave it as plus or minus. So we have negative 3 plus or minus 2 root 5 all over 2. Okay. And then let's get that y-intercept on there real quick. Y-intercept is just the c, which is negative 11. Yeah, so this looks great. Now we go to graph it, and we're like, let's do the other stuff first. When we get to the x-intercept, this is going to have some fun things going on. All right. All right, I'm just going to do some of these. -3/2, okay, I'm calling this -20 down there. It's a sketch, we can do that. We can do that kind of funny business because it's a sketch. So axis of symmetry is that x equals -3/2, which is 1.5. So this is like our axis of symmetry right here. -1.5, and -20 is right there. So there's our vertex. Okay, y-intercept is at 0, -11. Okay, I'm just calling that -11. There it is. Okay, there it is. That's -11 because I said so, right? I just marked it. We can do that kind of stuff. All right, symmetric points. So let's reflect this across the axis of symmetry. So think it's 1.5 units to the right of the axis of symmetry. So go 1.5 to the left, and we're at this point right here, which is -3, -11. Okay, now the x-intercepts. I cannot quantify that, right? What? So here's the thing. These right here, this is the exact value of the x-intercept. Someone asked, what are the x-intercepts of this function? That is the exact answer. However, if I'm sketching, I need an estimate because I have no idea what that is. I can't quantify that. So I'm going to come down here and get an estimate, and the way I get an estimate is just to type these into the calculator and just do that, get an estimate, okay? So what I'm going to put in the calculator is -3 plus 2 √5, whoops, all over 2, okay? And I get a decimal approximation. I'm going to go out 3 decimal places. So I'll just say about approximately 0.736. So approximately 0.736 is one of them. And then the other one, we're just going to change this to a minus. And that one is about -3.736. Okay, and then that is what we can graph. We can try to graph the estimate. So if 1 is here, we've got one x-intercept that's almost at 1 and another one that's almost at -4. 1, 2. Okay, so we can kind of eyeball our estimates. But it's just that, it's an estimate. So like, let's say on the test, you had a question like this, and there was a blank that said exact, and there was a blank that said estimate. The exact is the one you can't graph. It's the one with the square root. The estimate is what you type in so you can get an eyeball where to put that. Okay? That's the last one, right? Okay, so you now have one example of every type that you're going to see on worksheet 9. Okay?